A-Level Pure 1 Sequences, an exercise on arithmetic progressions. Now the following is an exercise based on arithmetic progressions. Pause the video at this point and have a go at the questions. When you've done your best, restart the video and I'll go through the answers. Okay, question 1 says, the first term of an arithmetic progression is 3. The sum of the first 20 terms is 345. Find the common difference. Well, to solve this, we have the first term a is equal to 3, and the sum of the first 20 terms, that's S20, is equal to 345. Now, we've got the formula for the sum of the first n terms. That is, Sn is equal to n over 2 into 2a plus n minus 1 times d. And we're told the sum of the first 20 terms is 345. So if we substitute n as 20, we get 20 over 2 into 2 times 3 plus 20 minus 1d equals 345. And that simplifies to 10 into 6 plus 19d equals 345. Or if we divide by 10, 6 plus 19d is 34.5. Subtracting 6, 19d is 28.5. So d is 28.5 divided by 19, which is 1.5. So we have the common difference is 1.5. In question 2, we're told the first term of an arithmetic progression is 7 and the third term is 13. The sum of all the terms is 472. Find the common difference and the number of terms in the series. Well, to solve this, we have the first term is 7. That means a is equal to 7. And the third term is 13, so t3 is 13. Now we have a formula, Tn is equal to a plus n minus 1d. So, substituting n is 3, we get 7 plus 2d is equal to 13, which tells us 2d is 6, or d is 3. So the common difference is 3. Now, the sum of the first n terms, Sn, is equal to n over 2 into 2a plus n minus 1d. And if we substitute d as 3, and the sum of the first n terms as 472, we get n over 2 into 2 times 7 plus n minus 1 times 3 is equal to 472. If we double both sides, we get n into 14 plus 3n minus 3 equals 944, or we can expand the bracket and simplify and get 3n squared plus 11n equals 944. Now to solve that, we put it in the standard quadratic formula form. That's 3n squared plus 11n minus 944 equals 0. Now, if we have a calculator which can solve quadratic equations, we can just type this in and get the answer. However, if we haven't, we'll have to use the quadratic formula. N equals minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is equal to 3, b is equal to 11, and c is equal to minus 944. Well, if we substitute those numbers in and then simplify, we get n is equal to minus 11 plus or minus the square root of 11,449 all over 6, or n is equal to minus 11 plus or minus 107 all over 6. So n is equal to 16, or n is equal to minus 19.66 recurring. Well, the number of terms must be positive, and so n must be 16. So we have the common difference is 3, and the number of terms is 16. In question 3, we're told the fifth term of an arithmetic progression is 21. The 10th term is 1. Find the first term and the common difference. We're then told the sum of all the terms is minus 63. Find the number of terms. Well, we're told T5 is 21 and T10 is 1. And we've got the formula Tn is equal to A plus n minus 1 times d. So substituting in 10 and 1, we get A plus 9d equals 1. And substituting in 5 and 21, we get A plus 4d equals 21. So if we subtract, we get 5d equals minus 20. In other words, d is equal to minus 4. So the common difference is minus 4. Now, if we substitute that into A plus 4d is equal to 21, we get A plus 4 times minus 4 equals 21. A minus 16 equals 21, so A is equal to 37. Now we're told the sum of the first n terms is minus 63. And the sum of the first n terms is n over 2 into 2a plus n minus 1 times d. So if we substitute a as 37, d as minus 4 and Sn as minus 63, we get n over 2 into 2 times 37 plus n minus 1 times minus 4, and that's equal to minus 63. If we double both sides and simplify, we have n into 74 minus 4n plus 4 is equal to minus 126, and we can write that as a quadratic equation, 4n squared minus 78n minus 126 is equal to 0. Well, we can either solve that on a calculator if it's got the ability, or we can use the quadratic formula. N is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is 4, b is minus 78, and c is minus 126. Now that simplifies down to n is equal to 78 plus or minus the square root of 8100 over 8, which is 78 plus or minus 90 over 8, which is 21 or minus 1.5. Well, n must be a positive whole number, and so n is equal to 21. So the number of terms is 21. In question 4, we're given that in an arithmetic progression, Sn is equal to 2n squared minus 6n. And we're asked to find the first term and the common difference. Well, we've got Sn is equal to 2n squared minus 6n. And if we take n as 1, the sum of the first term is just the first term, t1. So t1 is equal to 2 times 1 squared minus 6 times 1, which is equal to minus 4. So the first term, a, is equal to minus 4. Now if we take the sum of the first two terms, that's t1 plus t2. So t1 plus t2 is equal to 2 times 2 squared minus 6 times 2, which is 16 minus 12, which is plus 4. So t1 plus t2 is equal to 4, but t1 is minus 4. So minus 4 plus t2 is equal to 4, so t2 is 8. Now the common difference is the difference between the second term and the first term, t2 minus t1. So d is equal to 8, take away minus 4, which is 12. So the common difference is 12. In question 5, we're told the sum of the first 5 terms of an arithmetic progression is 140. The sum of the next 4 terms is 238. Find the first term and the common difference. Well, we have S5 is equal to 140, and S9, the sum of the first 9 terms, is equal to the sum of the first 5 terms, which is 140, plus the sum of the next 4 terms, which is 238. So S9 is equal to 378. Now we can use the standard formula. Sn is equal to n over 2 into 2a plus n minus 1d. And substituting n as 9, we get 9 over 2 into 2a plus 9 minus 1d is equal to 378, which gives us 9 over 2 into 2a plus 8d equals 378. And if we expand the brackets, that's 9a plus 36d is equal to 378. So a plus 4d is equal to 42. Now that's our first equation. Now if we look at n is equal to 5, we have 5 over 2 into 2a plus 5 minus 1 times d equals 140. So 5 over 2 into 2a plus 4d is equal to 140. And if we expand the brackets, that gives us 5a plus 10d is equal to 140, or if we divide by 5, a plus 2d equals 28. So we have two equations, a plus 4d equals 42, and a plus 2d equals 28. And if we subtract, that gives us 2d is equal to 14, or d is equal to 7. Now we can substitute that into one of the equations. A plus 4d equals 42, and so a plus 4 times 7 is 42. A equals 42 minus 28, so a is 14. So the first term is 14, and the common difference is 7. In question 6, the sum of the first 9 terms of an arithmetic progression is 315. The 9th term is 6 times larger than the first term. Find the first term and the common difference. Now we have the sum of the first 9 terms is 315, so S9 is 315, and the 9th term is 6 times the first term, so T9 is 6 times T1. Now we've got the standard formula, Sn equals n over 2 into 2a plus n minus 1d. So if we substitute n as 9, that gives us 9 over 2 into 2a plus 9 minus 1d is equal to 315, which simplifies to 9a plus 36d is 315, or if we divide by 9, a plus 4d is equal to 35. Now, we can use the formula Tn is equal to a into n minus 1d. Now T9 is equal to a plus 8d, and we have T9 is equal to 6a. So a plus 8d is equal to 6a. In other words, 8d is equal to 5a. And this gives us two equations. A plus 4d is equal to 35, which we can double to get 2a plus 8d is equal to 70. And 8d is equal to 5a. Well, we can substitute the 8d. So we get 2a plus 5a is equal to 70. 7a is equal to 70. So a is 10. Now we know 8d is equal to 5a, so 8d is equal to 50, or d is equal to 6.25. So the first term is 10, and the common difference is 6.25.